Good afternoon. Thank you very much for taking time out of your afternoon to join us for our masterclass in how to achieve net zero in medical device manufacturing. And I'm going to hand over to Colin Martin, who's driving this afternoon.
Brilliant, thanks Sinead. And just to echo again, good afternoon everyone. Thanks very much for taking the time out to attend today. Appreciate everyone's busy. It's a busy time of year, and really do appreciate the fact you guys are taking 45 minutes of your precious time to come and listen to myself and Dara. So hopefully this will be worthwhile. And so just let's kick off without further ado. And 2050 should be pretty familiar in everyone's psyche at the moment. You might have picked up on my accent and my location just a few miles up the road. Lots of very important people are speaking about this very important topic, literally right now. So certainly from our point of view, in the business we're in, we've been in this business for nearly 13 years. 2050 seems like a firm milestone, seems quite far away as well, but actually it probably isn't. And the 2020s really has to start to be the decade of action, at least on the first pass, to start us moving towards a more sustainable future. And with any chance of hitting the carbon reduction targets, particularly in the European Union that's set, we really need to start doing something pretty soon. Another driver of it is the ever rising price of carbon. 2 years ago, it was down at 6, 8, 9, 10 euros a ton. Just this year, it's gone above 60 for the first time and is now getting sustained above 60 on a consistent basis. And from our side, the way we're looking at this, we see that going up to 70, 80, 90, 100 euros a ton towards the end of the decade. And it probably needs to be at that level to drive the whole carbon reduction targets that have been set and to sort of really engender that cultural change in moving us away from fossil fuels into more sustainable forms of production and living. Similarly, to sort of support that, we've seen a number of false dawns in this business. The EU is also talking about a border tax around the trading blocks. Any products coming in need to pay the equivalent level of tax that they would have paid if produced in the EU. That will slightly change the game as well for the likes of China and the US, that they inevitably will have to start bringing in some form of carbon trading scheme in their jurisdictions as well. So all the markers, all the indicators are it's moving forward, and there's going to be pressure on everyone to do their bit. I mean, analysts are saying they could see, some analysts saying 200, 350 euros a ton carbon dioxide. Now, if that happens, okay, that's going to focus the mind even more. No one is really coming out saying, yeah, it'll drop back to 2015. That's not really going to happen. Despite it being a political market, so on, that's really not the case. It's only really going to go one way. The focus of today for people with fixed installations and in factory in the manufacturing world is the scope 1 and 2, your direct and indirect emissions. Scope 3 is important, don't get me wrong, but also scope 3s, your scope 3s is another person's scope 1 and 2s. So what's directly controllable, influenceable and actionable right now in your portfolio and your responsibility, it's your 1 and 2 emissions. Say scope 3 are important, but 1 and 2 is where you can make immediate impacts as we move forward. Really need to emphasize that net zero is going to be a journey. It's not going to be a one and done exercise. It's going to be an iterative process, and it's going to require a number of passes to get there. And who's to say what that actual ultimate goal is? Is it net zero, and then look beyond that? Do we need to actually start taking carbon back out of the atmosphere and become negative carbon? Now that's second half of the century potentially, but as I say, it's not going to just stop with a good first pass and a good couple of projects. How we see that theoretical net zero continuous improvement process working is from the digitalization of data and the digitalization of energy. What we mean by around the digitalization of data is pooling all the data sources available to people in the production facilities and manufacturing plants and at corporate level. Now, in the plants, you have your SCADA systems, you've got laboratory information management systems, quality management systems. You have a utilities plant, whether it's boilers, cooling towers, compressed air plant with disparate PLCs and their own data historians, often not connected. So rich sources of data there. You have maybe some metering systems that have been put in for the water, for the effluent, for the gas, so on. Again, not necessarily linked to the SCADA, very valuable source of information. And plant logs, whether in a spreadsheet or actually written down by hand, particularly on refrigeration plant, HVAC systems and so on, their operating parameters, hertz, frequencies, things like that. Useful information again. And then moving into your engineering maintenance management systems, production information, to find that necessary correlation. You could treble your output. Does your energy go up 3x as well? Correlating that information gives you great insight. So bring all that information together into one central collection, collated place. Have it at your fingertips, have it clean, verified, no gaps, no spikes. It's all there, ready to be analysed and used. Produce all the reports. We all love a good report, CSR reports, central reports, P&Ls, profit, yields, uptime. All that information comes from those data sources. Produce all the reports daily, weekly, monthly, quarterly, annually. From that same data and the reports, bring your subject matter experts, bring your resources to bear on identifying your problems and opportunities. We could make a saving by changing X. We could make a saving by changing Y. Identify what that is and then decide to take action. In our experience working across a range of industrial sectors, it's two sort of strands of changes. They're the operational changes. It's a bit of maintenance. It's a set point change. It's a tweaking of the control parameters. So take that action, confirm the effect over the short, medium and long term is how you would then maintain it and come back round on the process again. On the equipment change, slightly different. Potentially need to apply for funds for CapEx. We need to do a concept design, a front-end engineering design, more detailed design. Also get it into the budgetary cycles for CapEx if there's none available in the immediate period. That's potentially then waiting for those ideas to go in, get budgets to get approved for implementation the following year. And often there can be long lead times and shutdowns required. But in principle, if you said you're going to double throughput or take 50% off the specific energy consumption per unit produced, you implement that change, confirm that effect has been delivered and achieved, and then move on to maintaining that over the short, medium and long term and come round again to start the process. So from a net zero point of view, just again, our experience of looking at this is potentially how the first year to 12 months plus of that cycle might look in terms of a data audit, identifying where you have gaps in all those data sources, and there could be metering and instrumentation that's required to be installed. Gather all the data, analyze for what you have, and that can be offline as well as with live connections, and then really start to look at certain solutions. We always recommend the first step that Dara will come on to, which is optimize what you're consuming right now with the equipment you have. Then look at the potential solutions to further reduce your carbon burden at that point, whether that is through renewables, whether that is through other more exotic electrification of heat and decarbonisation strategies around those. This would then take you through into that first full year with commissioning and install in the second half of that year. And then once you've maximized the commercial returns, which again we'll come on to later on in the presentation, you come back around and start that process again. Look at what's phase 2, look at what's next, and how you just further work forward to hopefully minimize, eliminate, and potentially in the future even be a carbon reducer, a negative carbon provider. So I will now hand on to Mr. Terrett.
Thanks, Colin. And hi, everyone. And as Colin and Sinead said already, thank you so much for your time today. These kind of discussions are so important, not just from an industrial and profit kind of point of view, but also very topical and poignant, as Colin mentioned, with the Glasgow Climate Summit happening right now. Obviously, as a business, we have been helping our customers drive towards initiatives like net zero, lowering emissions, lowering your energy consumption, and ultimately lowering costs and increasing revenue. In the past, whether companies would admit it or not, profit is the key driver and always has been. That's still the case. That's the world we live in. But hopefully from today's session, you can take some starter value points away and run with them to get to that roadmap to net zero. So back to today's content, getting a grip and increasing your knowledge base on your current utilities and systems is paramount to help you deliver your decarbonization goals. Sounds simple and straightforward, but like anything, you need a starting point. So Colin, if you could go to the next slide, please. Yeah, so typical electricity consumption. What you can see on the screen there, that's a typical energy breakdown on a pharmaceuticals plant, albeit different plants with different processes will have slightly different breakdowns. It's not a one-size-fits-all representation, but it is reflective of the utilities used from an electrical standpoint. HVAC typically representing anywhere between 50 and 75%, which encompasses all of those services feeding into the HVAC. We'll be going through various measures that can be allocated to reduce consumption in both electricity and thermal, that usually generate savings anywhere between 5 and 35%. Obviously, this is dependent on site conditions and whatnot. Carl, if you could go to the next slide, please. Thermal breakdown. So this is an indicative thermal breakdown with percentages. Similar to the electrical breakdown, it will differ from site to site. Key points here is the breakdown of direct versus indirect steam and the temperature requirements within the processes. So clearly identifying your temperature profiles within the overall system is very important to give you a clear overview. Can you go to the next slide, please, Carl? So typical consumption reduction methods. All of these points listed are basic areas where you need to start and cover first if you haven't already. Distribution systems need to be optimized. You know, again, basic stuff that is often overlooked. Stuff like having drip legs in the correct location in the steam network, for example. Not usually a priority, but like those kind of low-key actions can have significant positive impacts on the quality of your system, which ultimately leads to increased efficiencies within the processes. Control optimization obviously delivers quick and impactful changes, as can load configuration. AHU operation and controls will impact not only the thermal, but your electrical consumption also. And all of these are very good starting points and should be the first port of call when applying resources to energy saving initiatives, and to concentrate first on the equipment that is already in play before moving on into installing new technologies. So back to you, Carl.
Colin, you're on mute.
Yeah, apologies, my mouse wasn't working there. Thanks for that, Dara. So yeah, okay, what's next? I think it's still with you, Dara, isn't it? Because I think you're our solar expert these days.
Apologies. Yeah, so solar technology has progressed to a point where it's becoming more and more feasible. So certain choices around your installation will make it that much more feasible depending on how you marry it up with other technologies available. Like squeezing the most you can from a solar install is key. Otherwise, it just becomes another CSR exercise. But the reality is it actually can be so much more. It can help create that step change. So you as a company is stepping outside of those CSR obligations to actual beneficial outcomes. Can you go to the next slide? Yeah. So over the last 10 years, as can be seen from the slide, the implications of mass production by certain countries like China has allowed for the cost per module being produced to decrease significantly, almost by 90%. And even though the installation of solar has increased in most recent years, the cost of that installation around ancillary equipment or labor in certain regions around the globe, like the Middle East and areas in the US, the cost is averaging out at circa 1 to 2 cents per kilowatt hour, which has led to the cheapest electricity ever produced. In Southern Europe, you're talking circa 3 to 4 cents per kilowatt hour, and combining solar technology with other technologies such as battery storage, which Colin will be taking you through. This can add huge value to your solar installation, along with generating grid services, value from the grid. And it's this kind of holistic approach when you leverage numerous technologies together that you can create impactful step changes to your plant's energy consumption and carbon footprint. So all of which is hugely encouraging to confidence levels in the reality of net zero approach and decarbonization. making the next decade a time of huge opportunity, and finally allowing for technologies that have been around for a while now, but through development, those technologies can now make those sustainable changes and hugely impact how we generate and consume. If you can go to the next slide, please, Carl. Yeah, so solar on your roof. So there's a saturation of options out there currently providing roof-mounted solar solutions. The only big differences would be around offerings of deploying microinverters or string inverters, but generally, a good rule of thumb would be 1,000 square meters of roof space would equate to in and around 320 kilowatts of solar peak. In Ireland, those peak periods would account for circa only 900 hours versus Southern Europe, where you'd be looking at over double that, around 2,000 hours per year. So just sticking with Ireland for the moment, for that 320 peak, you should be getting in and around 30,000 euros in electricity savings a year, and 100 tons of carbon or CO2 equivalent. But the key is, again, to squeeze and maximize that opportunity as much as possible. And this is where taking that holistic approach, which I keep mentioning, is so important. Again, I mentioned batteries as one of those components, and leveraging grid services is another. The third component would be around monitoring, analyzing, and building predictive models on your solar. If you could go to the next slide, please, Carl. Yeah, so solar performance monitoring. Performance monitoring on any asset or utility is hugely important. Solar would be no different, especially when you include other data sources outside of your solar equipment data available. So you'll also want to collect meteorological data, radiance data, ingest them into a single platform, along with all of your other energy and utility data and operational data available. And just the next slide, please. Yeah, look, that's just an example of global horizontal irradiance data coming in. And if you could go to the next slide, please, Carl. Yeah, so this dashboard, look, I can only speak on behalf of our capabilities and our own platform, but this would be an example of a modeled or predictive generation capabilities based on all of those live data points I mentioned. So outside of solar, just for one moment, if you can imagine similar dashboards to this being leveraged by our clients around predictive outputs on utilities, and processes, enabling and giving them the ability to make key decisions, leading to increased output in tandem with decreasing energy consumption, ultimately enabling the best KPIs possible. But sticking back to the task at hand and this dashboard, what you see in blue, those blue blocks, they're actual generation on site or from this array. If you go back to the previous slide, Carl, sorry. Yeah. So what you can see in blue is the actual generation, and in green is the predicted generation, right down to an hour ahead, if you so wish. And that red trend you can see trending over the two bar charts, that trend graph represents the confidence of this prediction based on all of the variables to hand. Like this kind of dashboard allows for a number of different key value adds. First being, it's always beneficial to have an idea of future generation of your array. It allows you to make certain decisions which enable the most effective consumption of your generated and your grid energy. Also taking into account different tariff times, the energy market, and the best time to export if that's an option for you. Also, the most beneficial time to leverage your battery installation if you do have one. So all of these components come together along with another that I will be touching on later to really make that road to net zero more of a reality. If you could go to the next slide, please, Colin. Yeah, so this is an operational dashboard, and this allows for operational insights, which can be visualized through the dashboard, but more importantly, in the background, it's sending alerts and emails to the right personnel, notifying them to certain thresholds being breached, possibly a dip in generation efficiency due to a problem with an inverter, or simply the need for certain zoned modules to be cleaned. And the way we have set this up on our platform is that these alerts will go out and give the user enough time to rectify the problem before large potential revenue is lost. And sorry for handing over so quickly there the last time, Carl, but I think it is handing back over to you now this time.
Magic, thanks for that, Dara.
Thank you.
So yeah, we mentioned earlier there batteries, excuse me, and how they can help in the transition. A key technology, and much like solar PV, their costs have reduced exponentially over the last 10, 15, 20 years. And they've really hit that 80, 90% cost reduction. A man in the news, Elon Musk, and the world of Tesla, that's been part of that driver. Obviously, as more factory and capacity gets built, innovation brings along, it's cheaper per kilowatt hour, so on and so forth. The flip of that as well is with solar PV in recent months, with people coming out of the pandemic and really decarbonisation starting to take off, those prices have ticked up a little bit, but the broad thrust of that 80, 90% reduction is in play. Certainly for batteries, we would always recommend, if you're looking at solar PV, always think about a battery to go in with it. Now, generally, if you're putting it on the roof in your fixed installation, your factory, you're pretty much going to self-consume all that electricity during the day. Potentially, if you're only a 24/5 operation or a 16/5 operation, at the weekends you're going off, that is then when potential surplus in the battery could be stored in a battery. But generally, if you're 24/7, you're going to use all that PV in your plant, unless you're quite fortunate to have a lot of land adjacent to the factory and you're considering a larger ground-based installation. So again, the surplus that would be generated in peak hours could then go into a battery to then be fed back into the plant. And it gives you a strong decarbonisation message. And there's also a strong fiscal benefit there. The solar power, once you've paid for the installation, is in essence free. You're not selling it back to the grid, you're going to use it and offset it against your bills coming in. And in that same principle, the battery can also open yourself up to a simple commercial play. Charge at night when electricity is cheaper, and discharge during peak periods during the day when electricity is much more expensive. And as we touch on in slightly later in the presentation as well, there is going to be a time in the future, particularly in Ireland, UK, Western Europe, when you may even be getting paid to charge your battery at night, such as the excess generation from renewables and the low levels of demand. So that's potential just to bear in mind for the future. This is a rule of thumb as well. If you're putting in a solar PV, the battery starting point should roughly be twice the size of your kilowatt peak array. So if you're putting in a megawatt, 1,000 kilowatt peak solar array, your starting point for consideration of battery should roughly be double, 2,000 kilowatt hour. Again, that's dependent on local site conditions and an actual survey and understanding of your exact requirements. But as a starter for 10 rule of thumb, that's what we would recommend. Always, 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 though, we emphasize optimize your existing consumption first before then looking at the new technologies, because again, if you could save 40% on what you're consuming just now, then that is going to influence the sizing and the requirements on solar batteries and so on. Some of the key considerations on battery tech: it's got to be racks. You've got to be able to get in there to do maintenance, to do change outs, and they will degrade over time. So you need to upgrade the cells, so on and so forth. You want to be optimized for high power applications. Your industrial sites, you have industrial requirements. You're not wanting a commercial or domestic scale battery. You want it to be able to deliver 400, 420 volts, whatever the voltage is. You want to deliver at the hertz, and you want that instantaneous power available very quickly. That's why we're saying the response time should be 20 milliseconds or less. So if you have a 2 megawatt battery, it comes up and is available within 20 milliseconds at 2 megawatts, or whatever your site requirement is at that point in time. Some of the benefits we're touching on is, and we'll come on to these later in the presentation, is the grid services that are available from these particularly fast acting products. A battery can pretty much react instantaneously to any frequency variations it observes on the grid, and it can act then to stabilize the supply into the plant and also into the grid nearby. And those can be very lucrative from a revenue point of view. So again, stepping back and coming into a holistic solution where you are decarbonizing, but yet still maximizing your commercial returns to try and give an overall a good return for a decarbonisation project. The batteries are an essential building block of that whole approach. There's also fringe benefits from a technical point of view in terms of voltage support, power quality improvements, and site power factor correction that the site gets. It's quite hard to put a fiscal sum on those, but they are invaluable in terms of preventing premature failures of equipment, preventing brownouts, dips, and potentially the site could get then up to an hour of UPS at full production. You know, so if the grid were to go down for any particular reason, potentially with a battery, you have an hour to start to do some load shedding, get prepared. Hopefully the grid comes back up and on, in which case no problem. Or then you'll be able to sort of shut down non-critical systems in a calm and measured manner and not have too many sleepless nights. This is just as a real life example of some of those fringe benefits we mentioned. Blue line there is the voltage dip limit, and the graphics there, the various colors. Green is low risk cases, the purple is medium risk cases, and the red is high risk cases. And before this actual battery energy storage solution was installed, this was the number of cases. So they're in the filled in, and you can see a number of red cases. That's where the plant is heavily at risk in terms of brownout, some of the voltage dip, and potentially for equipment damage and failure. The greens are the low risk, and the mediums are, as I say, medium, so relatively close. After the actual system was installed, which is these hollowed out figures, generally you can see all of them moving up and to the left. And that is to safety. The number of actual high risk cases is vastly reduced, over 50% reduction. See someone just on the line, but they are on the safe side of the line. And even on the low risk cases, again, generally they're moving up and to the left. So what that means is if you have right now power quality issues, then a battery solution, whilst giving a decarbonisation play, whilst giving a direct fiscal commercial benefit through arbitrage and other mechanisms that we've described, will also give you a technical benefit, which is ultimately a fiscal benefit as well. And it's also to say that in the future, and we'll come on to grid services slightly later in this presentation, there is going to be potential services around voltage support for the grid. And the reason for that is just the increasing numbers of renewables that's going to come on to all grids as they look to decarbonise. Ireland is possibly leading in that regard in terms of the level of non-synchronous generation it's looking to bring onto the grid in the very near future and beyond. So yeah, I'll now hand back over to Mr. Terrett, who's going to talk about another technology that will help on the decarbonisation journey.
Thanks, Carl. Yeah, so heat pumps is the other technology I alluded to earlier. Again, a technology that's been around for quite a while, and it's becoming more and more relevant in the current climate. Powered by green power and the grid, they are very valuable assets on that roadmap to decarbonisation. Providing green thermal energy to site, whether in the form of hot water, but also potentially green steam, allowing game-changing step changes to that decarbonisation process. So this next slide that Colin's gone on to, the UK project kind of build out around heat pumps. In terms of the projected build out of heat pumps in the UK, they have been very progressive, far more progressive than the rest of Europe. Even after leaving the EU, they have stuck to their goals and their targets. And this lays out that projection over the next 15 years, hitting very high numbers, and those numbers, a lot of which will come from the industrial sector. So if you want to go to the next slide, please, Carl. Around consideration. So some of the main considerations to take into account when installing a heat pump would be, firstly, to identify waste heat sources currently on site, which could be used to prime that heat pump. So taking that waste heat or ambient even to pump that to a higher, more useful temperature level. And we have progressed enough over the years in this space to have experience and knowledge, not just operating in those usual conventional output temperature levels, but work and deliver in the uncrowded space of delivering those higher temperature outputs. There's not a lot out in the industry that are dabbling in those high temperature spaces. So some quick examples and not limited to these sources of heat, would possibly come from your effluent plant, generally around 20 to 30 degrees, depending on what your washdown and CIP temps are. Another source of waste heat would come from your AHU extracts, possibly your vacuum pump exhausts, and again, also ambient, especially in summer times. All of these can be used to prime a heat pump. The second big consideration is the gap between gas price and electricity price. So electricity being used to obviously run the heat pump to displace the use of gas or oil, preferably oil. What is that gap between the prices, and does it make sense to install a heat pump? And that's outside of the holistic approach. If you can leverage solar and battery possibly to supply the electricity needed to run the heat pump, the business case becomes possibly more desirable. So it's all about your current conditions and what you can and cannot do. Ideally, you want as high a COP as possible. You will find out there currently COPs running between 2 and 6, depending on the configuration of the heat pump and the gap between the two temperature levels. That consideration is probably the most key for me to getting an acceptable payback. Thirdly, leveraging the heat pump to access grid level services, which, as Colin mentioned, he'll be going through in more detail later in this presentation. And lastly, can you use the heat pump to generate high temperature outputs, like I spoke, i.e. steam? So if you want to go to the next slide, please, Colin. Yeah. So this next slide is a configuration we are currently working on with a number of our customers. It's obviously excluding some details as they are live projects, but it's a 3-stage heat pump, each stage with a different technology and a different refrigeration gas. First stage, lifting temperatures from circa 30 to 65 degrees. Second stage, from 65 to 105 water or atmospheric steam in a reboiler arrangement possibly, and then to 2-bar steam in the final stage. A lot of sites will have existing steam infrastructures in place, and obviously there would be a huge expense in removing that and replacing with hot water. So that's where green steam can really play a relevant role, powered by green electricity. At the intermediate stages, you can draw off heat after the first and second stage to provide those lower intermediate temperatures required to supplement HVAC, AHUs, domestic hot water, and potentially boiler feed water. So this is really an example of a configuration that can make that huge impact on your scope 1 emissions on site. And where we've used this in the past, we've seen up to 85% of gas or oil consumption being reduced. So decarbonizing really significantly for those clients. If you can go to the next slide, please, Carl. So like with the solar, proven technology, the technologies harnessed to do this have been around for quite a long time. It's the bespoke nature of the configuration that's important here. And if you can crack that, or perhaps allow us to crack it for you, it's the kind of holistic approach that myself and Colin have been talking about throughout this whole presentation that will allow those huge step changes to be made on site. And that is it from me. Back to you, Carl.
Yeah, thanks for that, Dara. So how can grid services help in this whole transition and this whole journey? We've mentioned them quite a bit through the presentation, and there's a specific reason for that. If Ireland is, and indeed elsewhere in the EU and the world, is serious about hitting their targets, they're going to have to use more renewable power, full stop. That's the end of the discussion. 2020, around about 42% of all the power generated and consumed in Ireland was from renewable sources, which is a pretty good effort. Of that 42%, so of the whole 100%, 36% was from wind, as in, so 36% of the 100% generated was from wind, and about 6% came from other renewable sources. So wind is the dominant renewable energy source in Ireland, as it is pretty much in the UK as well. We're well placed, being the coastal island states, to harness the wind that's lashing in off the Atlantic. Feels like every day, even in the summer. Now, at times in Ireland, it can be even higher than that 40%. So the instantaneous peak has been reached, was 89% back in February 2020. Generally, the grid boys are not too happy with that level at the moment, but they are working to have that a higher level of sustained instantaneous demand being generated by these non-synchronous sources. So what exactly does that mean? Basically, they're looking to move up towards 80, 85% for longer, being from wind and other sources of renewable generation. And if you think about it, if you're going to actually achieve, say, 80% of your annual demand from renewable sources, then there's going to be times when you actually need 200, 300, 400% of the demand being generated by renewables, and then you need to store it for use later on, when the wind's not blowing or when demand increases, and so on. So grid services, as the name describes, is how potentially some of those gaps can be plugged through storage like batteries and thermal stores, and also from reducing demand on the grid as well. So there's two kinds of markets. There's the very developed markets in Ireland at the moment. In fact, I would say it's a global leader in the grid services market because of the all island nature of it. And the two markets specifically in play right now are the DSU, the capacity market, and there's the DS3 auxiliary services market we'll come on to just shortly. The capacity market it's straightforward. You have basically demand side units, so people who have plant, maybe generators, maybe machines they can turn off, maybe a heat pump that can be turned off with notice to reduce demand on the grid. If you have natural gas backup, if you have water storage vessels, so on, then you have some resilience of supply, some ullage to keep your process and plant running. You're therefore potentially can turn on your standby generators as well. If you're called upon to do so, generally with about an hour's notice, that is what you would be requested. So for every megawatt you can contribute of capacity that could be turned off or reduced upon demand, you'll get paid a rate per megawatt, as we see up on the screen there. And it's quite generous. And also, you may never get called upon to actually turn your generation on or reduce your demand. But you provide that capacity, that availability for the grid operators, the network operators to make that request of you. Now, this is relatively slow acting in that you'll get a phone call to say, 4:30 this afternoon, we need you to turn off 2 megawatts. As you've said you can, please do that for us. And that's how that works. For anything between 2 to 6 hours, depending on which tariff mechanism you're on. The ancillary services, slightly different. These are the fast acting products. 0.1 milliseconds reaction we're talking here. This is batteries and other really fast acting responses, acting autonomously with control signals, going at the speed of light, that sort of thing, picking up a slight deviation from 50 to 49.5 hertz on the grid, and the battery kicking in to bring that hertz and that frequency back into the refined tolerance range. Again, there is a payment per megawatt available there. You can see in those fast acting products up to 20 minutes, quite lucrative, from 20 minutes out to about 8 hours, less lucrative. And then the 8 hours plus is really for the big power stations kicking in, as there's been a major issue, elsewhere. So those are the two elements that can be brought in. So if you can think about it, heat pumps that can be flipped off quite quickly. If you have standby generators that can be brought into service as required, then you have a battery for really accessing those fast acting products. Tie that all together with efficiency measures with your solar PV, so on. It's sort of lending towards a really attractive holistic solution that can provide a return whilst providing decarbonisation, and are giving you a platform to then move on to your next phase of your decarbonisation journey. So pulling these all together in a hypothetical, this is what, from an electrical aggregation point of view, potentially what a site in the future looks like, with everything connected in. But you have your battery, you potentially got electrical vehicle charging stations, and we've not even touched on the future services around vehicle to grid. As I mentioned, the more wind that's blowing at night, it needs to be stored. Potentially, you could be getting paid to charge your car at night. You could also be eventually being paid to plug your car in to provide support to the grid at other times as well. That's not here now, but certainly with the macro trends in the markets, that's the way grids are moving, the way the grid services are going to move. And you don't see a combustion engine car advert anymore. It's all electric or plug-in hybrids at the very worst. we're all going to have electric cars in 5 to 10 years, that's for sure. From the net zero model here, from where Coley can really provide real value to any clients is bringing all this together. You know, this is complex arrangement of how we grid services, battery storage, all the technology, the energy conservation measures would work. Our software platform Clarity be in the midst of that, with the algorithms knowing when to make a commercial play on the battery, when to turn off your heat pump following the signal from the grid. And one of our major minor shareholders in our group, TKO, can bring finance, transition funding to these sort of solutions. You know, so if CapEx were tight or you were looking to expend your CapEx on other areas, there is a potential sort of option there that we can bring that finance into these kind of solutions at very, very attractive rates. So succinctly, this is how we would propose a lot of people's journey to start. Do your optimization. Make sure you're not wasting or squandering energy on your current portfolio. Make sure that is as tight and an optimal performance as possible. Then look at the grid services, what heat pumps can do, solar and batteries, with wind and potentially hydrogen coming into that mix in the next few years. Wind's a bit tricky in domestic situations, industrial units, but it certainly can be looked at. But these plays here are available immediately right now. Clarity in the heart as the glue layer can provide you with that accelerated CO2 reduction right now. And that, ladies and gentlemen, thank you for your time. Thank you for your patience. Thanks for listening. Brings us to the end of the webinar. So I think we can open up to questions and answers.
Yeah, a couple of good questions there. The first good one is why is roof PV cheaper than ground? I know, Colin, you've got a good answer for that. I do.
Generally, because when you install on the roof, you've got most of the existing structural steelworks in place via the roof. Therefore, the rack mount on the roof is far cheaper than ground mounting. Ground mounting requires more structural support, steelwork, if you will. Therefore, on a per kilowatt hour basis, it's more expensive. However, if you have sufficient land that you own or lease adjacent to the factory, bigger is better. You get an economy of scale. That could be a very interesting option. And there's already been some examples in the press of people doing that. Putting in large scale solar on the ground because you're not limited by your roof space. And again, you can get a higher self-sufficiency from that install. So it'd be a slightly higher CapEx, but if you do it big enough, then the return can work. And again, you tie in some batteries with that to store your excess and feed that back into your factory, a very attractive return.
Dara, I heard you talking about combining parts for when you're doing solar. Are battery projects commercially viable without integrating solar, etc.?
I would say they are, Colin. Solar wouldn't be a must. I think you could. It depends on each bespoke situation. Obviously, it's a lot more applicable if you have some kind of renewable energy on site that you can feed into that battery solution. But look, every site is different. There's a solution for every site. But yeah, that would be my answer to that. Unless Colin wants to add to it.
No, it's definitely a viable solution. But again, with all of this, this is the high level. You need to get into the local conditions of what the process actually does, what and when, and then work out what's going to be the best solution. So certainly, it's not solar must have a battery or battery must have solar. But in our experience, that more holistic approach is how to sort of blend all the paybacks together to get the biggest bang for the buck early on in this sort of whole decarbonisation journey that all our industry is going on.
I was on mute, sir. Sorry. Last one, very quickly. If you're going to start your factory's journey to net zero tomorrow, where is the best place to start?
As Colin mentioned at the end there, I think starting with the basics, optimizing, what you have on site already. And I know that's a very open-ended statement, but even if you can bring parables to sport, starting with the basics is always the best thing to do at the beginning of any journey. And how to do that, I think digitizing your factory, it sounds like a mammoth task, but getting data off the right utilities, allows you and gives you the insight to make certain decisions, even if you're not in a stage to go down that digitized journey. Look, there's lots of stuff you can do, like I went through at the start of the presentation and Colin at the end. Just make sure everything you have on site is performing as optimally as possible right now, before you start taking those bigger steps, albeit more interesting steps that Colin went through.
Gents, 14:45. I think we sign off. That was really, really interesting. Thank you very much. And thank you to everybody for joining us.